Hello, dear learners. Today we are going to learn about the set of real numbers. This is teacher Mary Jane. First is the set of natural numbers represented by letter N or counting numbers. So these are the numbers that we use to count. When we are counting, we always start with 1. That's why the lowest counting number or natural number is 1, followed by 2, 3, 4, 5, and so on. Okay, so in this diagram, this is where we find the set of natural numbers. Then the set of full numbers are the union of the set of 0 and natural numbers. So just include 0 to the set of natural numbers. So instead of starting with 1, we start with 0. Once we've included 0, so that is considered the set of whole numbers. Okay, so as you can see in this diagram, whole numbers cover natural numbers. Okay, it covers natural numbers. It means that natural numbers is a subset of whole numbers, the set of whole numbers. Next, the set of integers are the union of set of whole numbers and negative whole numbers and negative natural numbers. Okay, so we have and of course 0. We also include 0 here. Oh yeah, 0 is already included in the set of whole numbers. Okay, so here is our notation for integers. We use letter Z. And here are the sets. So we have -5, -4, and we have ellipses here and ellipses here as well. It means that it is an infinite set. Okay, so it has 3 subsets. The set of positive integers, and then we have the set of negative integers, and then the set including 0. Okay, so here are the notations for those 3 subsets. Okay, so in this diagram, integers is this circle, is represented by this circle. So again, it covers the set of whole numbers and natural numbers. The next one is the set of rational numbers. These are the union of the set of integers, fractions, and decimals. But take note, not all decimals are rational numbers. This should include the terminating and repeating decimals. They are numbers that can be expressed as a ratio or quotient of 2 integers, a over b, wherein b is not equal to 0. Okay, so here are the examples of rational numbers. By the way, we use letter Q to represent rational numbers. All right, so we have -5, so that is a negative integer, -2/3, that is a negative fraction, and then 0 3.75 a decimal, and then 5 a positive integer. Okay, so it is represented by this whole circle, which covers integers, whole numbers, and natural numbers. Next, let us define irrational numbers. So irrational numbers, on the other hand, are numbers that are non-terminating, non-repeating decimals, or radicals whose roots are not exact. So here are some of the examples of irrational numbers. So if rational numbers are represented by q, so q prime means that the number is an irrational number. Okay, so here are the examples: negative square root of 5, this decimal which is non-terminating and non-repeating at the same time, and then the square root of 2, the value of pi. Okay, so it is represented by this circle on the right. Now let's have these illustrative examples. So given 15, negative 12, 0, 9.35, 5 over 7, 8.25, and so on. The square root of 12, 8.25 with a bar on top, and then square root of 9. So which are irrational numbers? So let us identify the irrational numbers first. So square root of 12 is an irrational number, as well as this number, because it is non-repeating, non-terminating decimal. Square root of 12 is also an irrational number because it is not a perfect square. Okay, and it cannot be expressed as the, what do you call this, as the quotient of two integers. Letter B, which are rational numbers? Of course, when we remove these two, the remaining are 15, negative 12, 0, 9.35, 5, 7, 8.25, and square root of 9 are rational numbers. Okay, 15 is a positive integer, negative 12 is a negative integer, 0 is an integer, 9.35 is a decimal, 5 over 7 is the fraction, and then 8.25 with a bar is a repeating decimal, and square root of 9 is equivalent to 3, so that is an integer, okay, or a perfect square. So these are all rational numbers, which are integers. So integers are 15, negative 12, 0, and square root of 9, again because the value of square root of 9 is 3. Which are whole numbers? Whole numbers include 15 and 0. And last, alright, next we determine which of the following is true or false using this notation. So N for natural numbers, W for whole numbers, Z for integers, Q for rational numbers, I for irrational numbers, R for real numbers. Number 1, 25 is a natural number. Yes, that is true, because natural numbers starts from 1, 2, 3, and so on. Letter B, 1.125 is a rational number. So that is true because it is a terminating decimal. C, negative 3/5 is an integer. Of course not, because it is a fraction. So it is false. D, square root of 39 is an irrational number. This is true because 39 is not a perfect square. E, 0 is a natural number. Well, we have said earlier that 0 starts, or natural number starts from 1. So this is false. And F, square root of 100 is an irrational number. Since square root of 100 is a perfect square, so this is also false. Okay, next example, plot the set of real numbers in the number line, then rearrange it in increasing order. So we have positive 5, negative 8, 0, 11 thirds, negative 7 over 9, square root of 6, and the negative value of pi. Okay, so we have here the approximate values of the other numbers. 11 thirds is approximately 3.67. Negative 7 over 9 is approximately 0.78 or negative 0.78. Square root of 6 is approximately 2.45. The negative value of pi is approximately negative 3.14. Okay, so we can now plot these numbers given this equivalence. So 5 is very easy, so just plot it here. Negative 8 is here. 11 thirds is approximately 3.67, so it is between 3 and 4, so almost here. We have passed 0, so 0 is here, and then 3.67 is here. Negative 7 over 9 is approximately 0.78, so it is negative, so it is here between 0 and negative 1. And then square root of 6 is approximately 2.45, so it is here. Next, negative pi, so negative 3.14 should be here. Okay, let us move that. It should be here. Okay, let me remove that and put it here. Okay, so it should be here. Let us put an X on that. That is wrong. And we will extend this. Okay, so that is the answer for negative 3.14. So in increasing order, we start with the lowest, which is negative 8, followed by negative pi, followed by negative 7 over 9, followed by 0, followed by square root of 6, and then 11 third, and the largest number is positive 5. Well, thank you so much for listening to that discussion. Our next lesson will be on scientific notation. Once again, thank you so much for listening. This is teacher Mary Jane. Until next time, goodbye.